everyone, this is Majors. Today we're doing skill 15. It's not skill 15, is it? No, it's not. It's skill 22. Zeros of polynomial function. Sorry about that. So for each of the function graph below, state zeros of the function. So how should we go about that? How do you find zeros on the graph? Literally where it intersects with the x-axis. I'm going to use my highlighter first over here. Here, and here, where it intersects with the x-axis. So those are the points that it intersects. So let's go ahead and write those down. For f of x, my zeros are x equal to -2, x equal to -1, x is equal to 1. And it's a cubic function, right? 1, 2, 3. Do you guys remember how to identify the degree of the function by looking at the graph? Yeah, you just literally see how many directions it goes. So 1, 2, 3. Cubic, that makes sense. And remember algebra 1, you learned that number of zeros are same as the degree. So cubic, 1, 2, 3, check. Looks perfect. Now let's go on to the next one. Okay, so 1, 2, 3, 4. It's the quartic function, meaning it's the fourth degree. What are my zeros? My first zero is at -2.5 and my other zero is at x equal to 2. Oh boy, there's a problem. What's the problem? Well, since it's a quartic function, you should have 4 zeros, but how many zeros do we have? 2. So your teacher was wrong. No, he was not. We'll figure out why there's a gap of the number of zeros there. Next one, quintic. Well, 1, 2, 3, 4, 5. Quintic is the fifth degree. What are my zeros? X equal to -4, x is equal to -2, x is equal to 2, x is equal to 5. So I have 1, 2, 3, 4 zeros, yet it's degree of fifth. So there is a gap there. Some of you probably already know what is happening. Well, I'll give you a hint. What kind of function is that? Yeah. What kind of function is that? Yeah. So that has something to do with the zeros. We'll get there. Now, I'm going to teach you a new vocabulary. Okay, that is called a multiplicity. Okay, multiplicity of 0 is a number of times that 0 is a zero of a function. Number of times that zero is a zero of a function. So it has a multiplicity of 1, multiplicity of 2, multiplicity of 3, and so on. Okay, it will make sense once we look at this next section. So let's go. Read the following information about the multiplicity of the zeros while studying the graphs above. Then answer the questions on the next page, which is, by the way, just underneath it. So in graph f of x, all of the zeros have multiplicity of 1. Okay, so look at it. The very first one, it's saying that -1, -2, -1, 1, all of them have the multiplicity of 1. I'm just going to write it down here. Multiplicity of 1, multiplicity of 1. And I want you to kind of look at the behavior of the graph at that 0. I'm not talking about the overall shape. Like at that 0, what does the graph look like? Do you guys see how it's just going straight, like through the zeros? Yeah. So all those 3 has a multiplicity of 1. All right, let's keep going. In graph g of x, the zeros, x equal -2.5 has a multiplicity of a 1, and x equal 2 has a multiplicity of what? 3. Okay, so it says -2.5 has a multiplicity of 1, and x equal 2 has a multiplicity of 3. What I want you to do is look at the graph and see the behavior at that 0. Okay, so -2.5. It has a multiplicity of 1. Well, what does that look like? Well, for me, it looks like a line going straight through it. At x equal 2, if I were to zoom in near it, near that 0, what does that look like? Do you guys see how it kind of looks like a cubic function around 2? And it says it has a multiplicity of 3. So, oh, okay. And the fact that it says multiplicity of 3, that means that x equal 2 is going to be 0 how many times? 3 times. Because multiplicity means how many times that 0 is going to be the 0. That means x equal 2 will be the 0 3 times. And I'm going to show you what that looks like later in the function. All right, last one. negative 4, negative 2, excuse me, 5 has a multiplicity of 1. So these have a multiplicity of 1. And x equal 2 has a multiplicity of 2. So x equal 2 has a multiplicity of 2. Look at it. Negative 4, straight line. Negative 2, straight line. 5, straight line. At 2, if I were to zoom in, what does that look like? Kind of looks like a quadratic function. Why? Because there's a multiplicity of 2. So it kind of makes sense. Are you guys all coming together? So any zeros with a multiplicity of 1 literally goes through the graph, straight line. Anything with a multiplicity of 2, at that 0, it looks like a quadratic function. Multiplicity of 3 looks like a cubic function around it. So now let's summarize it. What do you notice about the sum of the multiplicity of the 0 and degree of the function? So it's asking sum of the multiplicity and degree of the function. Well, let's look at it. All right, what's the degree of the cubic? 3. What's the sum of the multiplicity? 1 plus 1 plus 1 is 3. They're the same. Let's go next. Quartic is the 4th degree. Sum of the multiplicity. 1 plus 3 is 4. Oh, okay. Now that kind of makes sense why there is a gap of the numbers there. Quintic is 5. Sum of the multiplicity. 1, 1, 2, 1. Add up to be 5. So sum of multiplicity is same as the degree of the function. Okay, so now that we talk about multiplicity, it makes sense. Describe the behavior of the graph as it approaches the 0, as you can see, where multiplicity is 1. So like these over here, at negative 2, at negative 1, at 1, what did it look like? It literally looked like just a line goes straight through. Kind of looks like a linear function around it. So it's either going to go up that way or go down that way. Right? Go up through it. Go down through it. Go up through it. Down through it. Down, up, down, whatever. You get the point? Okay. Now, sorry, I keep having to go back and forth. What does it look like around the multiplicity of 2? Where was it? Over here. Kind of look like a quadratic around it. So the line touches it, the 0, and bounce back. Or you can say looks like a quadratic. So what did it look like? At the 0, it's either going to look like this, or at the 0, it's going to look like this. I'm not talking about the whole shape. I'm talking about at that 0, like when you zoom in here. Okay? All right, last but not least, what did it look like when it has a multiplicity of 3? It looks like a cubic graph around it. So over here at 2, right? So around that 0, it's going to look like this. Around 0, it's going to look like this. Do you guys see the difference between the multiplicity 1 and multiplicity 3? Multiplicity 1 literally goes through it. Multiplicity 3, it looks like a cubic, so it's got to stop around at 0 a little bit with a 0 slope. Okay? All right, so now we're going to use that to come up with the equation that could represent the function graphed above. So I already copied this down from the previous page. For each 0, I just put the multiplicity of each one. So now let's go from there to come up with the factors. Ooh, I hope you remember. All right, what's the relation between 0 and the factor? If x equal negative 2 is a 0, then your factor will be x plus 2. X equal negative 1 is a 0, factor will be x plus 1. 1, x minus 1 will be the factor. And do you guys remember multiplicity means how many times that 0 happens? Well, all of them has a multiplicity of 1, so you're just going to write those factors just once for each. Done. Now let's go with this one. All right, x equal negative 2.5, so factor will be x plus 2.5. Be careful here. All right, it says x equal 2 has a multiplicity of 3, so that means it happens how many times? 3 times. So you're going to do x minus 2, x minus 2, x minus 2, because it has to happen 3 times there. Or you can write it as a x plus 2.5 times x minus 2 quantity q. So you can kind of think of the exponent of the factor as the multiplicity. They're going to be the same thing, because you know how technically there's a 1 over it. Yeah. All right, what about this one? Well, what that look like? It'll be x plus 4. That one, it will be x plus 2. That one will be x minus 2. But since it has a multiplicity of 2, square. And x minus 5. Okay, multiplicity matches with the exponent of the factor. Now the y-intercept, we'll look at the graph. I know your graph is a little off, but let's just uniform it. Okay, so this one, let's say the y-intercept is at -2, where it passes that y-axis. So y-intercept is at 0, -2. Over here, let's say that's at -2 as well, 0, -2. Well, technically y-intercept will be -2, but let's just use a coordinate. Okay. Last one at -3. I know it's not quite passing it, but for the sake of the problem, we're going to use -3. 0, -3. For your quiz and test, it'll be very clear. And your delta math. All right, now, are you ready? So what are we going to do? Now it's asking you to find the equation of the function. Well, we're going to use this factor form and this y-intercept to come up with the equation. Okay. Some of you might be thinking, well, wouldn't the equation of the function just be x plus 2 times x plus 1 times x minus 1? It might be, but we don't know. Well, why not? Well, then how will we use that y-intercept information for this problem? You wouldn't know. So you might remember from Algebra 2, you need to put the factor a in the front, because that's going to take care of whether it's going to be stretch or whatever, all that stuff. So to find it, you're going to put that a in the front. Okay, so let's just keep going with all of 3 as well. So y is equal to a times x plus 2.5 times x minus 2 cubed. The last one, will be y is equal to a times x plus, you can use any variable. I don't care. You can use x. Well, I guess not x. You can use k or whatever. But I'm using a. All right, now what? After you put that a in, you're gonna put 0, negative in. So 0 is gonna go in your x, -2 is gonna go in your y, right? So -2 goes in the y, equal to a times 0 goes in all your x's, 0 plus 2, 0 plus 1, 0 minus 1, and you're gonna simplify, okay? So -2 is equal to a times 0 plus 2 is 2 times 1 times -1. All right, looks messy. 2 times 1 times -1 is -2. So -2a is -2 divided by -2. A is equal to 1. So what's your final answer? Y is equal to, you can put 1 there or you don't have to. Let's just put it x plus 2, x plus 1, and x minus 1 as the correct equation of the function. Yay! All right, let's keep going. What about this one? What's the y-intercept? 0, -2. So x goes in, 0 goes in x, -2 goes in the y's. Plug it in. -2 is equal to a times 0 plus 2.5 times 0 minus 2 cubed. Oh, be careful here, because there's lots of place you can make mistake. 0 plus 2.5 is 2.5. 0 minus 2 is -2 cubed. Now, guys, do you multiply or do you do exponent? Oh yeah, exponent first, because that's what you do when you do the PEMDAS. So, what's -2 cubed? Is -8. Now what? I can multiply those two. It's only my calculator. So -8 times 2.5 is -20. So -2 is a times -20. So a is -2 over -20, which is going to be 1/10. So, final answer, we're writing the equation of the function. So, instead of a, you put 1/10 in. So, 1/10 x plus 2.5, x minus 2 cubed. Are you guys getting it? I hope you are. Last one, put 0, -3. 0 is x, -3 is y. So, -3 is equal to, this is long. 0 plus 4, 0 plus 2, 0 minus 2 square, 0 minus 5. But not bad. -3 is equal to a times 4 times 2 times -2 square times -5. -3 is equal to, -2 square is 4. Right? So 4 times 2 times 4 times -5 is a times -20. -160. So a is equal to 3 over 160. Don't be weirded out by the weird number. That's still fine. And notice I didn't put it as a decimal. I kept it as a fraction because I want the exact. So there we go. My final answer. All right. Thank you for watching.